Okay, on question 22, they are asking me to find the present value of a given future amount. So, first thing that you have to think about is the future amount, when we're talking about simple interest, is going to involve whatever you initially borrow or deposit plus the amount of interest. And if you think about interest, the simple interest formula says your I is equal to PRT. So this is the formula we're going to use to plug into with our future amount so that we can figure out what that P value is. So the future value is the 18,000. So I'm plugging that in here. I do not know how much or what the present value is, so I'm just going to leave it as P. Same thing here. It said my rate of interest was 7%, so remember, drop the percent and move your decimal 2 places to the left. And then I know that I'm depositing it for 10 months. And so again, you express that in terms of how much of a year, so it's 10 months out of 12. So now I'm going to actually just get on a calculator and punch out this part of it because we're going to round it to the nearest dollar anyway when we're finished. So I got 0.0583. And then this is understood to be a 1p, and then you're adding a 0.0583p. So if you combine those, that's where I'm getting this 1.0583p. In order to get p by itself, I'm dividing both sides by the 1.0583. And so notice that my present value ended up being $17,008. They didn't want nearest cent, they just wanted nearest dollar, so be careful with that. It will mark it wrong if you try to put the cents. On 23, now we're looking at compound interest. So when we're talking about compound interest, we're using a different formula. So this is my formula for compound interest. And so in this case, it said that I invested $13,000. So I'm plugging that in for my p-value here. This is just the number 1. My rate of interest, it said, was 2%. So I changed that to 0.02, and it is compounded monthly. So monthly means I'm dividing by 12 because there's 12 months in a year. And then I also have 12 as part of my power. And then it said that I'm depositing this for 17 years. So then at this point, you can go ahead and punch this out on a calculator. Depending on your calculator, you might have to put the power in parentheses or multiply it out first. So if you're not getting that, definitely practice on your calculator. Just push stop on my video, punch it out, make sure you get the same thing. So the first question said, what's the compound amount? That's the $18,259.15. The second question wanted to know how much interest was earned. So in order to do that, if you subtract the original deposit, that's going to leave you with the amount of interest. So that's where I'm getting the $52.59.15. Okay, so for number 24, I kind of ran out of room, so I came down here. We are going to use the same compound interest formula because they're asking me for, in this case, to find the interest rate when I have a $4,000 deposit that accumulated to $4,704. Here's that keyword compounded. That's how I knew to use that instead of simple interest. And it's compounded annually for 8 years. So they told me this time the A is the 4704. The P was the 4,000. I do not know what the R is, so I'm going to leave that in there. Since it's compounded annually, that meant once a year. So divide by 1 to the power of 1 times the 8 years. So I've got to do a little algebra first. I want to get the R eventually by itself, so I first started out dividing both sides by 4,000, and it's okay. I went ahead and went to a decimal here, just carrying 3 places. So 1.176 is equal to 1 plus R to the 8th, and the way that you get an 8th power to cancel is you take what's called an 8th root. So I took the 8th root of both sides. I didn't show it here, but what happens is that root cancels that power, which is why you're left with just 1 plus R. And then, of course, I subtracted 1 on both sides at that point. Now, to punch this into a calculator, you can either use, if you have an nth root button that looks like this, you can type it in directly. If not, You've got to know that an eighth root is the same as a power of 1 over 8. So again, I would stop the video and make sure you know how to punch that in and that you're getting the same answer that I did here. So the R ends up being 0.0205, but since they want your answer in percent form, when you go from decimal back to percent, you actually move that decimal 2 places to the right. So that's where I'm getting the 2.05%. Okay, on number 25, Susan Carver purchased a home for $410,000. It said she will use a down payment of 22% and then finance the remaining portion at 5.1% compounded monthly for 35 years. So in this case, we are using the monthly payment formula, but before we can do that, we've got to look at her down payment. So since she made a down payment of 22%, I'm going to multiply the original purchase price of $410,000 times the decimal 0.22, and that means that she made a down payment of $90,200. And if we subtract that from the original purchase price, then that tells us she's going to end up borrowing $319,800. So with my monthly payment formula, I was kind of running out of room, so I didn't write out the formula, but basically you take the amount that you borrow, and then you're going to multiply it, and you're going to take whatever the interest rate is. So notice 5.1%. I changed it to 0.051. It is compounded monthly because it is a monthly payment, so I divided it by 12. And then on the bottom, you have a 1 minus, a 1 plus, and you do the same thing. Your R divided by 12. And then on the power, notice that it is negative here. You put the 12 as part of your power and then the number of years. So you're really going to need to practice punching this one out. Probably the biggest thing that I can suggest is that you make sure you put parentheses around the top and these separate parentheses around the bottom. So make sure you know how to punch that out to get this monthly payment here. And then I will not ask Part B at all. We would do that on a spreadsheet if we needed. It's another formula we could use, but I won't ask that. But I could ask you about the amount of interest. And so if you're having to calculate how much interest, if you will take the monthly payment and you multiply it by 12 months in a year times the 35 years, and then you subtract the original amount she borrowed, that tells you how much interest she ended up paying. So again, you'll want to punch that out on your own. Make sure you're getting the same thing there. And then finally, on this last one, we're using the elimination method. So you decide ahead of time, do you want to cancel X or Y? I decided to cancel X. So in order to do that, I multiplied the bottom equation by -6 here. And so I'm doing that, notice, so that when I add these equations together, the X is going to cancel. Now you have to multiply the whole equation. So I had -6x minus 54y equals -444. And then I added my y's together. I got -55y. And then 4 plus -444 gave me -440. When I divided both sides by -55, then I found that my y was equal to 8. Once you have your y, you're going to plug it back into either of the original equations. I just happened to choose the first one. It really doesn't matter. So if I plug it in there, 6x minus my y equal 4, then I'm just solving, and I got x is equal to 2. So my solution here was 2, 8.